What's up, guys? It's Mr. Brengle, and today we're going to be going over the parallel circuits V equals I times R calculations, and this video is specifically for the wizard level. So if you're looking for help on the master level, make sure to check out my previous video on that level. Let's jump right in here to the wizard level, and I'm going to kind of go through some things that I did talk about in the master level. If you'll follow my marker here, the current goes through point A, and we talked about the analogy of a single lane highway up to this point. So all the electrons are in a single file line. They all have to follow each other. And then once it gets to this point, it splits into three branches, which would be the equivalent of a single lane highway turning into a 3-lane highway. So all of the cars that are on the highway are always there, but they can split up into different lanes. And just like with an actual highway, usually there's one lane that's moving slower than the other two and one lane that's moving the fastest. So you can have different speeds on the different lanes. And that's kind of how this works here. If you have different resistances here, then you'll have different currents going through each of these branches. But if you add up the current in each of these branches, it will always be equal to the total amount of current, which is represented at point A. So, for instance, you could have 100 cars that are on a single lane highway turns into a 3-lane highway. Well, even though they've distributed themselves differently within the 3 lanes, like you could have, 20 cars in one lane and 60 in another and 20 in another one. There's always 100 cars. So we'll want to remember that. Now, as the current goes through and branches between C and D, when it comes back around, the current going through branch D meets up with branch C right here. So point E represents the current from C and D added together. So these two branches have combined at this point. We now have more or less 2/3 of the current, assuming all resistors were equal at this point, and it is not including the current from branch B, but it does join up with branch B here, and then the total amount of current proceeds on this single lane highway back toward the battery. So we'll just want to remember that A represents the current of B plus C plus D, and E represents the current of just C plus D. So that'll be key here. Let's go ahead and write out our equations down here at the bottom. Voltage is equal to current times resistance. Current is equal to voltage divided by resistance, and resistance is equal to voltage divided by current. So that'll just be for reference as we go through here and do our calculations. So this one's set up a little bit differently than the last one. You'll notice that you're still given battery voltage, but this time it only tells us the resistance at resistor 2. So that's on branch C right here. So typically the first thing you're going to want to do is figure out how much current is on branch C, since we have that resistor. It does ask us for the current at branch A and at point A, on branch C and B and D, and then also the current at point E. So we'll have to figure all that out. Now, let's go ahead, like I mentioned, let's go ahead and start with calculating the current at branch C. Current is calculated by taking the voltage that's dropped across that resistor and dividing it by the resistor's value. So in this case, the battery voltage is 12 volts. As is the case with all parallel circuits, the battery voltage is applied across each branch. So you're going to have 12 volts that's applied across each of these branches here. And since there's only one resistor in each branch, each resistor will drop 12 volts. So when we calculate this, we're going to do 12 volts divided by the resistance at resistor 2, which happens to be 2 in this scenario. So 12 volts divided by 2 ohms is going to give us 6 amps of current going through branch C. Now, we have the current of branch C, it's 6. We have the current of branch D, it's 2. When you add those two together, it gives you the current at point E. So we know that there's 8 amps of current at point E. Now, it's told us the total amount of current at point A, which is 12. So there's obviously 4 amps left over here for branch B. So like when we add C and D together, that gives us 8. We know there's a total of 12. 12 minus 8 is 4. So there must be 4 amps of current remaining here in branch B. All right. So let's move on to our next one here. This time it's given us, again, battery voltage and resistor 2. So we can go ahead and solve for the current in branch C. Let's do that. That's going to be your battery or the voltage dropped across that resistor, which in this case is going to be 18, divided by the resistance of 6. That's going to give us 3 amps of current in branch C. Now, it has not given us branch D this time, but it did give us how much current is at point E. Remember that point E is a combination of C and D. So if we know that there are 5 amps at point E, there's only 3 in branch C. That means there must be 2 amps in branch D. Then all we need to do is add up B, C, and D, and that's going to give us our total current here. So 6 plus 3 is 9, plus 2 is 11. That means there must be 11 total amps of current in this circuit. Moving on. On this next one, it's actually given us the total current of 12 and then 2 of the branches, which adds up to 9. So that tells me that there must be 3 amps of current in branch D because these 3 branches need to add up to 12. We can then add C and D together to get 9 amps of current at point E. And then all we need to do is go back and solve for the resistance at resistor 2. That's going to be calculated using this form of the equation down here. We're going to take the voltage that's dropped across R2 and then divide it by the current that's going through R2 or on branch C here. So that means that we're going to take 18 volts divided by the current going through branch C, which is 6, which means that this resistor, 18 divided by 6, is 3 ohms. Moving on here, this time we do not have the battery voltage. However, we can solve for it here in a minute. This has given us 2 of the 3 branches, C and D, and it's given us the total. We're missing branch B. So since there are only 8 amps of current between branch C and D, that means there must be 12 amps of current in branch B because these 3 numbers must add up to 20. So there are 12 amps of current here. And then if we just add C and D together, we get 8 amps of current. That is what's going to be found right here at point E. Now to solve for the voltage, voltage is calculated by doing current times resistance. We know that the entire battery voltage is going to be dropped across R2. So what we can do is, since we have resistor 2's value, we can multiply this by the current going through that branch. So current 6 amps times resistance of 4. That's going to give us a battery voltage of 24 volts that we'll put right there. Okay. Last one here. Looking at this initially, it has told us that point E has 11 amps of current. We know that that's a combination of C and D. So I know that this number must be 6 amps so that it adds up to 11. And then since we're given the total current of 15 amps, and we know that these 3 numbers right here must add up to 15, 11 of them are accounted for between branches C and D. That means there must be 4 amps of current going through branch B. Again, we're going to solve for resistance 2 right here by taking the voltage dropped across that resistor, which in this case is 30 volts, and dividing that by the current going through branch C, which is 6. So 30 volts divided by 6 amps is going to give us 5 ohms of resistance at R2. That should do it for us here. We've completed the table, and that's going to be your parallel circuits V equals I times R calculations wizard level. Again, if you need the master level, go back and check that video. Make sure to let me know if you need any help.